morning. Today we're going to continue our look at oblique triangles. A reminder that in our last lesson we solved examples from the first two cases. In the first case, we looked at when we were given two angles and one side length. And the side was actually opposite one of the given angles, and therefore it had the same letter name. So here's the example we did. We were given both angle A and side A, so we were using the sine law twice in this problem. The second case was called the ambiguous case. This is when you're given only one angle and two side lengths. And we did two different examples. In the first example, we were given both side A and angle A, which meant that we could use the sine law. However, we found that when we found our first angle, which was C, it could be either acute or obtuse. We had both the quadrant 1 and the quadrant 2 possibility, and so we had two different solutions for that triangle. We did a second example from case 2. This time where we were given side B and angle B. So we were able to again use the sine law. But when we found that first angle, which was C, the only possibility was the quadrant 1 acute angle. When we tried using 180 minus this angle, we got something that was too big for our triangle. And therefore there was no second solution, just one solution. So again, that was for case 2, which was called the ambiguous case. All right, so we did the first two cases in our last lesson, and I'd like to begin now with case 3. Now, you'll note in these examples today that we will not be able to begin with the sine law because we will not have both side A and angle A, or both side B and angle B, nor will we have side C and angle C. Okay, so let's get started. Here's case 3. This is when you're given two sides and their included angle. The included angle means the angle between the two sides. And because it's between the two sides and not opposite either side, it will have a different letter name. Like this one, side A, side B, angle C. Okay, so I'm just going to show you the picture. Side A, side B. See, angle C is between them. It's called the included angle. And the key is we can't use the sine law because we don't have two things with the same letter name. So we have to start with the cosine law. And since we're given these three items, we will start with this third form here of the cosine law. We know side A and B. We also know angle C. So we'll start by finding side length C. Okay, so let's get started. So we begin by substituting into this formula for C squared. This should say 27.2. Oh, I'm going to get my liquid paper. Just give me 1 second. Okay, and now I'm going to show you how I would punch this in. Now, For the Casio calculator, you can simply go left to right. So 184 squared plus 125 squared minus 2 times 184 times 125 times, the multiplication here is optional, the symbol, times the cosine of 27.2 is, we get this number. This number is the square of C. So if we want the value of C, we take its square root and we write down 92.6, and I'm rounding to 3 significant digits, just like these sides here. Okay, I forgot to write down the 3 things that we were trying to find in this question, so I'm going to do that now over here. So obviously we want to find the missing side length C, but not only that, we're going to find the 2 missing angles A and B. Remember, there will always be 3 things that you need to find when you solve the triangle. So now we've done this. Okay, the key now is that we have side length C and also angle C. So now we can use the sine law. We have this full ratio specified. So I can write side C over the sine of angle C equals, now here it is important to know which angle I must find first. Actually, you should find the smaller of these angles first. So that's a rule that applies for case 3. So I'm going to state that rule right here. Find the smaller angle first. Okay, so let's put a star there. This applies for case 3. I'll explain why when we do our calculation in a moment, okay? For now, how do we know which is smaller? Is angle A smaller or angle B smaller? We do know the 2 side lengths. We have A is 184 and B is 125. In fact, the smaller angle will always be across from the smaller side. So hopefully that makes sense to you. You can see it by looking at this general triangle here. For this triangle, look, here's side A, and it is smaller than side B. Now look at the angles across from them. Angle A here is smaller than angle B here. Okay, so in fact, angle A is acute, angle B is obtuse. So the smaller angle is opposite the smaller side. The larger angle is opposite the larger side. Okay, so that's always true. So our smaller angle for this question will be B. So that's how I know to put B over sine B here in my formula. Okay, so now we can substitute. Side C is 92.6. We put that over the sine of 27.2 degrees. And we're going to set that equal to 125 over the sine of angle B. So we're going to be finding angle B. We'll use cross multiplication now. Okay. Then we divide Okay. Now look, the last answer I got here was the 92.6. So it's stored in the calculator as the answer. So I can use my answer button here to recall this number. And that's a nice way of maintaining all of the accuracy. Okay, so I'll show you what I mean. We just use this button to clear that. And now I can punch in 125 sine 27.2 divided by, and instead of punching in 92.6, I hit the answer button. So it'll be dividing by that unrounded version of 92.6. And I get this number. So this number is the sine of B. Okay, so that number right there represents the sine of B. Okay, so if you want to have part of it written down, you can. All right, so I'm just going to write the beginning of it and just show that it certainly continues. Without clearing this now, I do the sine inverse. Shift, sine, equals, and that gives you angle B, and it's 38.1 degrees. Okay, so now I have angle B, the smaller angle determined. Okay, and now an explanation as to why I found this smaller angle first. The calculator, when we do the sine inverse, only gives us the acute answer. So it only gives us this answer. It doesn't give us the quadrant 2 angle that is also going to have this as its sine. By finding the smaller angle first, we're ensuring that we want the acute angle from the calculator. Okay, so now how do we find the missing angle? Angle A, well, we can just use subtraction now. There are 180 degrees in every triangle. We can subtract the given angle and angle B that we just calculated, and we will get 114.7 degrees for angle A. Okay, so always find the smaller angle first, since that angle will be acute and it will be the angle that your calculator gives you directly, and you won't have to think about the cast rule if you follow this rule. Okay, so that's an example from case 3. You're going to have to start with the cosine law to find the missing side length. Once you've done that, you'll be able to use the sine law. Just follow this one rule. Find the smaller angle first. It'll be opposite the smaller side. So B here is a smaller side. So we found angle B first. The last angle can be found with subtraction. Okay, we're going to do one more example. It is case 4. This final case is the case when we're given 3 side lengths. Now, obviously, when you're given 3 side lengths, you will not know any one of these ratios, since you will not know any angles, and therefore the law of sines cannot be used to start the problem. You have to begin with the law of cosines. Now, the question is, which form should you use for the law of cosines? Well, there is a general rule here as well, and it is find the largest angle first. Okay, so first, let me state that what we need to find in this question are the 3 angles, so uppercase A, B, and C. we have to begin with the cosine law. And the rule for this case is opposite the rule from case 3. For this case, we find the largest angle first. How will we know which angle is largest? Again, it will be opposite the largest side. So here, the largest side is C, and that means the largest angle is C. And therefore, the largest angle is C. Therefore, we use this third option for the law of cosines. Okay, so we are going to be using this last version since we have to find angle C first, since it is the largest. Okay, I'm going to show you how to rearrange this formula in order to isolate the cosine of angle C. Okay, so since this term is negative, I'm going to bring it to the left side. So it'll be like this. Positive 2AB cos C is, okay, so it went to the left side, so it could be positive. On the right side, we already have A squared plus B squared. We're going to move this term to the right side, so it is subtracted. Okay, so this is what we do first. So this went to the left right here. So now it's positive. This went to the right and it was positive. So here it is subtracted. Lastly, isolate the cosine of C by using division. So we divide by 2AB. Okay, and this would be the same process if you were using either one of these formulas. The manipulation would be the same, okay? All right, so now we're gonna get started. We're gonna plug in our side lengths here. So we're going to do 128 squared plus 146 squared minus 222 squared. We have to push equals and then divide that by 2 times 128 times 146. Okay. If you want to do it in 2 steps, no problem. You can work out the top number first. So 128 squared plus 146 squared minus 222 squared. So this is our top number, negative 11,584. And in the bottom, we can work out 2 times 128 times 146, and that's this number. Okay, so when we divide top by bottom, we'll get an answer for the cosine of C, and then we can take the cosine inverse in order to find angle C. Okay, so I've got this as the cosine of C. So we do shift, cosine. Here we go. We're going to get this angle, 108.1. So when the sides have 3 significant digits, the angle goes to the 10th. That's 108.1 degrees for angle C. So now angle C is determined, and we can cross it off of the list. All right. Oh, so now this is so a quick explanation as to why we did the largest angle first. Basically, when you use the cosine law and you had a negative answer here, right? So which quadrants have negative cosine? Quadrants 2 and 3. If you remember the CAS rule, okay? Just a quick reminder. So where is cosine negative? Here and here, quadrants 2 and 3. This is the quadrant 2 angle right here that the calculator gave us directly. It makes no sense to consider the quadrant 3 angle because an angle in this quadrant is more than 180 degrees and is therefore too big for the triangle. So we can be assured every time when we find the largest angle first, the calculator will give us the correct results directly without having to even think about the CAST rule. Okay? So follow this rule. You won't have to think about the CAST rule at all. Now that the big angle is done, we know that all remaining angles will be acute. There can only be one obtuse angle in the triangle. Okay, so now when we go to the sine law, we don't have to think of the CAST rule either. Okay, so we will go to the sine law now because we know both side C and angle C. So we'll do this. And now it doesn't matter which one we find next, because as I said, we already took care of the large angle. So both these will be acute. So you can find either A first or you can find B first. So I'm going to find angle A first. So now I'm going to substitute. Okay, so it's 222 over the sine of 108.1 degrees is 128 over the sine of A cross multiply first. 222 sine A is 128 sine of 108.1 divide okay, and it's time to do this calculation. Now again, I have this angle already in the calculator stored as my last answer. So if I want, I can use the answer button in this next calculation. So I'll show you how, okay? You don't strictly have to, but it helps to make sure the rounding is perfect. Okay, so watch. So clear, just this button for clear. And then you do 128 sine of the answer divided by 222 is, and you get this. Okay, so this number is the sine of A. I'll just write down a bit of it, 0.548. But I show that it's actually going on and on and on, right? Okay, and now we do sine inverse. So shift sine equals, and we get 33.2 degrees for A. And that is angle A. Right up there. Okay, so if I didn't use that answer button, then of course I'm just doing 128 sine of 108.1 equals divided by 222 is that, and then sine inverse Okay, and I'm getting the same thing, 33.2 degrees. Okay, lastly, the last missing angle B can be found from subtraction. So 180 degrees in the whole triangle. We will subtract angle C and we will subtract angle A, and we will be left with 38.7 degrees for angle B. Okay, so just a quick recap. Today we looked at case 3 and case 4. Case 3, you were given two sides and the angle between them. You have to begin with the cosine law. Then when you switch to the sine law, it's imperative that you find the smaller angle first. For case 4, we were beginning with 3 sides. And therefore, we were starting with the cosine law to find our first angle. This means we have to start with the largest angle first. It'll save you so much trouble if you do this. If you do start with the largest angle first, you won't even have to think at all about the cast rule. Everything will work out perfectly without any consideration of the cast rule. Okay? All right, so 4 cases in total. I want to show you really quickly. Your textbook has a pretty nice summary. This is at the end of chapter 9.5. It's actually on page 302 of the most recent edition of the textbook. Okay, so this is at the end again of Actually, this is in exercise 9.6. I think I said 9.5 a second ago. Sorry about that. This is in chapter 9.6, right before the exercises. Okay, there's a summary of case 1, 2, 3, 4. You can read through it. 2 sides and 1 angle was case 1. 2 sides and the angle opposite one of them. And remember that this is the ambiguous case. Case 3, which we did today, 2 sides and the included angle. Look, it even tells you find the smaller unknown angle first, okay? And case 4, the case of 3 sides. And you can see that it tells you use the law of cosines to find the largest angle first, okay? So a nice little summary, I think, that you might want to look up in your textbook as well. Don't forget to check Blackboard for your recommended practice problems. Okay, thanks a lot. Have a great day.